All right. So we talked about the business analytics process before. We said that business analytics starts by understanding the problem, collecting the data, cleaning up the data, exploring the data, analyzing, and then presenting the data, or presenting the data. Text, because text is more complex than traditional data, traditional numbers, and traditional analytics, the text analytics process has a couple of extra phases, or at least one extra phase. Okay, two extra phases. Okay, so always we start with the problem we are trying to solve. So a problem can be, I'm working for a political candidate, and this candidate wants to understand the problems or the things that are of interest to the people right now. Okay, so this can be a problem. Or another problem is, I want to understand how people feel about a product, my customers feel about a product I'm selling, right? So all of these can be problems or situations that you want to address using text analytics. Then you go and extract your data. And extracting text data is harder than numbers. Numbers, you just go to a database and get all the numbers you want. Text, in many cases, you have to go to the web, or you have to go to Amazon reviews or to Twitter and retrieve the data yourself from there. And this takes time and money, and we'll talk about that later on. Now, once you get your text data and you feed it into your computer, as I said, the computer will see the data as characters, as letters and numbers and semicolons and dashes and so on. It will see text as characters. So it's meaningless. What kind of information can you get from characters? A character is a character. It means nothing. It's an atomic value that has no meaning in itself. So we need to convert these characters into meaningful parts of speech, meaningful text, right? So we have a phase here called parse and filter text. Parse and filter text, this is where these characters of text are converted into words and phrases that we can analyze later on, right? So in this phase of parsing and filtering text, this is where we convert text into words and phrases and other things that I talk about in a minute, right? And we use this to analyze further as we go on, right? Right. So now we have words and phrases. That's wonderful. Now there is some structure in our data. We can look at words and understand what a word means. But the problem is, all data analytics algorithms are statistical algorithms. They are based on statistics or numbers. And therefore, how can we use words and phrases to create a statistical model? There is no way on earth to do that. There is no way. If I give you 100 words and I tell you use these words to create a statistical model, or use this to do an addition or subtraction, you are going to call me crazy, right? How can I subtract words, or how can I add up words or multiply words? There is no way on earth, right? So we have to have another phase here called transform text. Transform text takes the words and phrases that we have and converts them into numbers. And I will show that to you again today. I will show you how text is converted into numbers. And once we have text as numbers, we can start doing our magic. We can do classification, categorization, sentiment analysis, transform our text into numbers. So these two phases, parsing data, parsing text and transforming text, these are two phases that are unique to text analytics. These two phases do not exist in traditional data analytics. Okay. And then once we transform our text, then we can explore it, we can visualize it, we can analyze it, we can communicate it, we can do anything that what we traditionally do with numbers. Okay. But the two key things are these two phases: parsing your data, your text, and transforming it into numbers. We already talked about that. All right. So before I continue any further, does anyone have any questions yet so far? Raw text. All right. So we start with the first phase of, not the first phase. The first phase is understanding the problem and collecting the data. This is similar to traditional analytics, so I won't be talking much about that. What I want to talk about is the first phase related to text, which is parsing the text. So we are going to go through this and then go through a presentation on how to do it and what are the main concepts there. And then we are going to apply it on JMP and more importantly, the enterprise miner. In text analytics, I find the enterprise miner to be the strongest software out there to use in analytics. Okay, numbers, JMP is pretty straightforward, but when it comes to text, JMP has capabilities, but these capabilities are very few. So we will be using, I will show you what you can do with JMP, and then we will move and use the enterprise miner as well. So I'm going to share my screen again. Give me 1 second. Okay. I'm just finding the slides. Text pre-processing. Okay. All right. Okay. Right. So the first thing is, again, because it's important and related to parsing the text, is to understand that most 95% of the text we work with, especially in social media reviews and so on, is unstructured. Right. So when the computer and software sees text, it sees text as characters. Like text analytics is seen as text space ANALYTICS, right? It doesn't understand what are these. It doesn't understand there's something called word, something called phrase, something called sentence. It doesn't understand this, right? And we need, the first step for us to do anything with text is to convert this text into words, convert them into sentences and so on, to be able to understand what they mean, right? Before we start, there are a couple of definitions that we will be using throughout our discussion. The first one is the document. Okay, a document in text analytics is the unit of analysis. So if you are analyzing Twitter data, then each tweet is called a document. If you are analyzing files, then each file is a document. Okay, so a document is the unit of analysis. If you are analyzing Amazon reviews, then each review is called a document. Okay, a corpus is all the documents in our data set. So if we are analyzing 100,000 tweets, then these 100,000 tweets, they are called a corpus. If we collected all Amazon reviews about some product, then all these reviews are called a corpus. Okay, so these are some terms that I may use as we speak or talk about text analytics, right? So the process of dividing text characters into words and phrases is called tokenization. Okay, tokenization. The word tokenization, to understand it, I want you guys to look at this sentence. Hello, I like milk and honey. If I tell you to identify the words here, how would you do this? How would you tell me the words, not what are the words, I'm not interested in the words. How would you differentiate between the words in this sentence? How do you know hello is a word, I is a word, like is a word, milk is a word, honey is a word? How do you know that?
Dude, that's how you're taught?
This is how you're taught. But if you are teaching a kid to read, how would you tell them to understand the words here?
By
Yes.
knowing the letters.
Commas and spaces, right? When you see separator
Uh-huh.
between, right? When you see space or comma between two words, that tells you these are two different words. So this comma after hello tells you whatever is before the comma is a word. This I has a space before and after it, so you know it's a word, and so on. So we don't think about it because we learn it since we are 2 years old or 3 years old. So it becomes like our second nature. So it's we don't think about it. But this is how we actually do it, how we are able to identify words in a sentence by looking at separators or delimiters between the words, right? And this is exactly how the tokenization happens. A tokenization is a process, a computer process that has been there for 30, 40, 50 years. And this tokenization focuses on going through sentences and going through characters and separating them into tokens or words based on the separators or delimiters between them. So a tokenizer would go read HELLO and then find a comma and therefore consider hello to be a word. It would go to a space and then LIKE and then another space, and it will say that, okay, like is a word or a token. Okay, in programming language, in computer science language, it's called a token. Okay, so tokenization is the process of cutting our text characters into tokens, or you can call them words, or in most cases it's words. Okay, so when I use token or word, it's the same thing, right? So tokenization is the process of cutting, of dividing our characters that are being read into the software into words or tokens or phrases or whatever you want to call them. Okay. Now, in computer science, we have two approaches for tokenization. One of them is called up-bottom tokenization. So this is very similar to Excel. When you are using the search and len functions in Excel to separate text into words, this is an example of up-bottom tokenization. So you search for spaces and then you say anything between two spaces is a word, anything between space and end of sentence is a word, and so on. Okay, so this is the up-bottom tokenization. The other approach is called bottom-up tokenization. Okay, bottom-up tokenization is you go character by character. You start reading the string of characters one by one. So you read the I in the I love Canada below here, for example. You read the letter I, and then you see a space, and therefore you say that, okay, whatever came before the space is a token. And then you continue reading LOVE, and then another space, and then you say anything before the space was a token, and so on. So this is bottom-up tokenization. In most cases, bottom-up tokenization is the most commonly used one. So this is the most commonly used approach to tokenize text data in the industry now. Okay, it's faster. It has been there since the beginning of time. We have been using it even before we had text analytics. So it's very understandable and very efficient, and so on. Okay, things look simple, right? So now all I have to do is I have to get my text. I have to look for commas, spaces, semicolons, dashes, question marks, and so on, and then divide my text into words, and I'm done. Thank God, everything is so simple, right? Well, not quite, because we have some challenges when we are parsing our text. So we have things with delimiters being part of the word itself. Like Yahoo, for example, it has an exclamation mark at the end. So it should be included as part of the word. It shouldn't be used as a separator. When we are talking about IP addresses that we talked about when we talked about the internet, 192.168.1.1, this is a whole token. This is one word. This is one address. So we should look at it as one address, but it has dots between it. So how can the tokenizer understand this is one word and not just 4 different words? Hyphens like X-ray or caregiver. This is one word again. So how can we convince the tokenizer or the parser to understand these are one words, and so on and so forth. Even harder, since we are using the internet, things like emails or and URLs with dots and at and so many things. How would a computer program understand that the dot in www.senecacollege.ca, these dots are part of the token. They are not separators, right? So I shouldn't get www alone and CA alone and so on. Emoticons. Emoticons are very common, especially if you're analyzing Twitter or social media data, right? How can and they are represented as characters like two dots and then a parenthesis. How can a parser or how can a tokenizer understand that this is a word? It's not a word. It's a couple of separators, guys. So how would a parser know that, right? So in order to manage this, we have to change the tokenization process a little bit, right? So now instead of going only one round on the data and separating them by separators, we go into multiple rounds on the data, right? So for example, if you look at the example here, Mr. Smith visited Amazon.com and bought a new sweater, and then emoticon at the end. If you analyze this data, in the first time we go through the data, the parser will work naturally. So he will separate Mr. without a dot, right? And the dot will be different word, and then Smith, and then visited, and then Amazon is a different, is a word, dot is a word, com is a word, right? To buy a sweater. And then the emoticon is divided into the colon and parentheses, right? And then another round, we'll look at abbreviations, okay? And then we'll combine, if it will look at abbreviations through the token. So it will see Mr. without a dot as the first token and a dot as the second token. So they will be combined together to form Mr. and so on. And then another round, we'll look at internet names or internet tokens. So something like Amazon.com will be combined together into Amazon.com, and this colon and parentheses will be combined together into smiley face. So how does this happen? How does the parser know that MR and dot form a token abbreviation, Mr.? And how does the parser understand that Amazon and dot and com together form one token? We have something that is heavily used, and I will show you an example in a few minutes now, called word lists. Okay, a word list is pre-compiled word lists that other researchers, other practitioners have built with all the abbreviations and all the internet names that exist in the world, right? So we have a long and big list that contains Mr., Miss, all abbreviations belong to this list. So the tokenizer, in order for the tokenizer to combine together abbreviations, the tokenizer goes through this list and identify the abbreviations and combine them together, right? So I will show that to you again in a few minutes. Right? So word lists are very common, and they are heavily used in text analytics. If you are using Python, if you are using SAS Enterprise Miner that we will use shortly, if you are using JMP, if you are using anything, you have to use word lists somehow. You will be using word lists somehow, and I will show you how to use them and how to build them in a couple of minutes. Right? Right. There is another way using the program logic, but this is very rarely used, right? So for example, you can tell the parser, if you see 4 numbers with dots between them, then this is an IP address, right? This happens as well, but word lists are the most common way to identify special tokens like emoticons, internet tokens, abbreviations, and other stuff that we will look at as we go on. Any questions so far, guys? Any problems here? All right, great. right? Okay, so this is an important topic in tokenization as well. Okay, let me show that to you in a whiteboard, not whiteboard. Okay, any language, including the English language, has something called stop words. Stop words are words that are very common but have no meaning in themselves, like the, a, an, above, in, on. These words are used to connect other words together, right? I sit on my chair. Uh, this is a book, and so on, right? So use them to connect words, but on them in themselves, they add no meaning. They have no meaning in themselves, right? These stop words have because they don't have meaning, we don't like to include them in when we're analyzing data. Okay, so stop words are very common words that have no meaning in themselves, and it is always a good idea not to include them in our analysis. Okay, there are two problems with stop words that can cause problems when we are analyzing our data. The first problem is it increases the number of words in our text, right? So instead of having 500 words in our text, we end up with 600 because of all the, a, and, or, and all of these no meaning words, right? And because we are working on PCs or on computers with limited capacities, if you increase the number of tokens too much, this will impact your ability to do the analysis. So we want to make sure we have as little words or as few tokens as possible. This is one thing. The other thing is, as you will see when we start doing the analysis, analyzing the data depends on looking at the number of appearances of the token or appearance of words. So if a word appeared 500 times, it is more important than a word that showed up only 200 times. So because these words are very common, they will appear so many times in your text that they can cause, they can appear to be important, but they are not important, right? And therefore, we try to eliminate stop words from our analysis. And I will show you in a minute where you manage stop words and how to stop using these words, right? Okay. Right. In some cases, we don't want to analyze words, we want to analyze sentences. So we extend our tokenization to sentences. So we look at sentence delimiters like dots, commas, semicolons, and so on. Okay. Another thing that is that can show up in some softwares, including the Enterprise Miner, but not in JMP, is parts of speech. Parts of speech means what kind of word is it? Is it a verb, a noun, an adjective, an adverb, right? In some very rare situations, part of speech can be useful. But in traditional business analytics, in the analytics that you do for marketing, for finance, for sentiment, in most cases we are not interested. They don't make any difference for us. So we will ignore them once we start working with our text analytics work. Right? Any questions so far? All right. Any questions about text analytics? Right. So let's open our JMP and let's try working. Yes, Mike, you have a question?
Yeah, I have a question. It's based on Watson. I tried to look it up, but I couldn't find it. But I was just curious how many spoken languages that Watson understands. Does that make sense? Like,
yeah.
I'm assuming it translates, or do you have to type it in, or does it translate as well?
Let me tell you something. I'm going to answer your question in 2 minutes. Okay.
Okay. You're awesome. I need to learn. Just shut the hell up and listen.
Right. So let's look at JMP, and by going through JMP, you will understand how many languages Watson understands. So I'm going to open JMP. Okay, let me close all of these things we have opened so far. JMP, unfortunately, does not have a very strong text. It has some text analytics capabilities, but not so strong. So I will just go through it to show you the things we talked about today. We talked about tokenization and parsing, stop words, and all of this nice stuff. I want to show that to you and demonstrate it. And then when we go to the enterprise miner, you will see the same thing on a bigger scale and you will really enjoy it, I promise. Right. So in the course document, guys, if you go to the course modules, you will find a data set called Amazon products. So in week 12, 13, module 11 here, I think, module 12, right? Module 12. You will find Amazon dataset right here. So I want you to download this dataset, please. Okay. We'll see if it will open. It may not open a jump because it's big, but it's really nice. We'll see if it opens. If it doesn't open in jump, we'll use another dataset. Okay. So this is going to download a file called 1429_1. And this file basically has reviews about Amazon products. Amazon products are products that are created by Amazon, like the Kindle, the Kindle Fire, and all of these things, tablets created by Amazon. Okay, so we are downloading this file, and I will open it using my jump. So I will go to File, and then Open, and then here I will select all data files here. Okay, downloads. Okay, and I will open this file. Okay, now depending on your computer, it can take some time. Okay, you can see that we have the name of the device, we have some ID, we have the brand, categories, what categories it falls under, keys, manufacturer, all Amazon, and so on and so forth. So we have so many information. The most important here is the reviews text. This is the text that we will focus on, right? So this is the reviews text. This is the actual reviews of the people, right? Of the customers, right? We have around 34,000 rows. So this is a nice sized data set. Okay. Is everyone okay opening this file, guys? Any problems? All right.
What
If you have
module is the file under, Professor? Sorry.
That's okay. It's in module 12, 13. I will show that to you again. It's on the modules, and then when my internet works. Come on. In my internet group. Okay. So it's right there under module 12.
Thank you.
Okay. It's called Amazon dataset. Yes, this is the one, Amazon dataset. Yep. Thank you. Please. Right. So now we opened the file.
Professor, real quick.
Yep. Yep.
I'm still learning this database management thing. Can you, I know you have to go to files and open, but I can't seem to get the file to come to my jam. It's just because I don't know all the steps. You know what I mean? Does that make sense? You do it real fast and I lose you
Okay.
when you go to bring it in.
Sorry about that. Sorry about that. Did you download the file? Did you download the file?
Yeah, I have the file, and it's not you, it's me. So don't be sorry. I'm the one who needs to be sorry.
No,
Yeah.
no, I'm sorry. That's okay. So file and then open. You open the file. And then you select from this drop-down list in the right-hand side, you select data files. So by default, it's all JMP files, but we don't want JMP files. We want data files just below it. Okay.
Cool, thank you. I see it now.
And then you should find a file that we just downloaded. Right. I'll give you 1 minute for everyone to
Cool,
open.
thank you. I have it now. Thank you for doing that. I won't forget it this time.
Okay, that's okay. Forget it. That's okay. I'll remind you again. I have no problem. Right. So now we will analyze the data. Now it's very simple to analyze text in JMP. All you have to do is to go to the Analyze tab, as we always do, and then you will find something called the Text Explorer. Okay. So I will click on my Text Explorer. Okay. It will open the window that you guys see here in front of you. And all I need to do is to pick the field with the text that I'm interested in. So I'm interested in analyzing reviews.text. This reviews text, this is the field I'm interested in. So I will just click it and click text columns. Okay. And you can see it will go right here. Right. Okay. And now we want to look at these properties because this is important and they may answer a question for Michael. So the first option here is called the language. So if you click language here, guys, you will see that JMP currently supports 1, 2, 3, 4, 5, 6, 7, 8 languages, right? So you can include any languages you want. All the languages share some properties. They all of them have separators, all of them have delimiters, and so on and so forth. There are some specifics about for some languages, of course, but it's not that they are not that different. All you have to do is to find a list of a word list like the one I will show you in a few minutes, and that's it. But the operations themselves, the tokenization process itself, is the same regardless of the language. And therefore, if JMP supports all of these languages, then probably Watson supports a much more bigger set of languages, right? The other things we specify here includes maximum words per phrase. So traditionally, if you are doing tokenization naturally, you don't include phrases, you only include words, right? We only include words in our analysis. But JMP, and when we use Enterprise Miner, same thing, they allow us to work with phrases as well. So this is what this basically is telling you is what is the maximum words per phrase. So your phrase should contain how many words in maximum. For example, a phrase like Amazon Kindle Fire. This is a 3-word phrase. Or something like Amazon Prime selling price. This is 4 words phrase, and so on. So here we are specifying what is the maximum words we want to have in a phrase. If you want phrases, we can put easily 1, and that's it, right? And then this is the maximum number of phrases. It is set to 5,000, but because we are using PCs and our PCs are not the strongest right now, so let's change this to 500 only. Let's not make it 5,000. Let's change it to 500. Okay. And then this is the minimum characters per word. So in each word, in each simple token, a token that is composed of 1 word, what is the minimum characters that would form a word? All right. We have 1 to 50, which is okay. Okay. And then I will talk about stemming in a minute, but tokenizing, you will find that we have 2 options in tokenizing here. We have basic words, okay, and this is the bottom way of tokenization. So it finds delimiters and separates them into tokens. Right? We have another way called regex. Regex is more sophisticated and it is built on a bottom-up approach in tokenization. And as I told you, regex is the preferred or this bottom-up method is the preferred method in tokenization. So we'll stick with regex. Okay. Now the things that I haven't talked about is stemming. So what is stemming? Okay. Let me explain that to you in a minute. And stemming is a very cool concept in text analytics. So I want to explain it in details. Right. So we have words that have the same meaning but come in different formats. So for example, we have run, right? We have ran, we have running, right? All these means that someone is using their legs to move fast, right? All of them has the same meaning, right? Again, because text analytics is very expensive in processing, you will see yourself when we start processing our data, it takes some time. So because text processing is requires a lot of processing power, and because they have these words have the same meaning, so we want to think of them as one word, or to think of them as something that is similar. What happens is stemming converts all these three words into the root. In English, in the language science, for science that studies languages, we have something called a root and stems. So the root of all these three words is run, and then these three words come from run, right? Run, ran, and running come from this word. So stemming simply gets rid of the stems and replaces them with the root. Okay, so this is called stemming. This is very popular in text analytics, and I strongly advise you to use it. Okay, I use it all the time. I use it all the time, except in very rare situations where it can cause problems. Okay, I will give you an example where it causes problems. Let's say I'm analyzing the data for NASA, for example, NASA. Okay, so I'm working on a data set for NASA, and two words show up: universe, okay, and university, Okay, these two words have completely different meanings. They mean moon and sun. They are completely different in their meaning, but they have the same root. Both have the same root, which is, I think, this is the root of both of them. Okay, so if I use the root for both of them, then I'm losing information. I'm losing important information. I'm not differentiating between universe and university, and this is problematic, right? So if you are working in a very specific domain, in a science domain, or in a very not general analytics, but very specific field of analytics, like for NASA, for example, for a research laboratory, for something like that, then you may decide not to use stemming. But if you are doing it for marketing, if you are doing it for political analysis or whatever, then really I encourage you to use stemming all the time. Okay, so in traditional analytics, use stemming. If you are working in a very small and very specific domain that is highly specified, then you don't. How do you know this? When you are working in this highly specified domain, you will gain the experience, and you will find research that has done that before you, so you will know. But generally speaking, you can use stemming. Do you understand the idea of stemming, guys? Replacing words with similar meanings but different spellings with one with the root, right? Is this concept clear for everyone? I hope so. Right. So now we are going to include stemming here because I said stemming is good. So I'm going to select stemming, stem all terms. Okay, and we are done here. We're not 100% done. We'll still do more things in a few minutes, but for now we are done. So now I'm going to click OK. And it will take some time to run, depending on your processing power. Okay. Once I will give you a minute, and then we'll talk about this window that showed up once we run it. Okay. All right. Did everyone get this screen, guys? Any problems? I don't want to go too fast, so I'll wait for a minute. All right. Okay. So now we have this screen, and this screen contains the most important words and the most important sentences we have in our text, right? So you will see things like easy to use, Fire TV, year old, works great, Amazon Fire, Kindle Fire, great product, great tablet, Amazon Prime, battery life, and so on and so forth, right? And then these are the words, the single words here. You can see we have great, use, tablet, love, easy, this is easy, Amazon, and so on and so forth, right? And when you see something like this with a dash beside it, that means tokenization happened here. Okay, sorry, not tokenization, stemming happened here, right? So great. So what can we do with these words and terms? There are many things now we can do to analyze our data. We can look at the most important we can look at the most important words in a graphical interface, and it's very famous it's a very famous view of data. It's called the word cloud. Okay, so if I click here on show word cloud, look what will happen. It should be displayed here at the bottom. Okay, the word cloud is displayed here below, and you see it all the time when you are going through the internet. If you see the words that are big, that means they are more important, right? And then these small words means they are less important. You can display it in a more appealing way. If you click on this red arrow beside the word cloud, layout, you can say centered, and it will look even nicer. You can see this is exactly how you see it. If you read analytics papers and stuff like that, you will see this. This is a very common view of a word cloud. Okay. You can have many options here, but this is one of the best graphical views of text outcome, text analytics outcome, right? We can change the color as well, so you can see its color is different now, so you can play around with it as much as you want. Okay. Generally speaking, guys, if you want to modify anything in a jump output, you find this red arrow. You click this red arrow, and you will find lots of options here. Okay, so to display this word cloud, I selected the text explorer and display options, and then I selected show word cloud. Okay, and then when I wanted to modify the word cloud, I click this red arrow beside it. I changed the layout into central, and the coloring I changed it into arbitrary colors, and it's nice. I can do it in grays. Okay, so it depends on your purpose. Right. Now there are other things that I want to show you today. Right. If you click here on the red arrow beside the text explorer again, okay, I want to show you the stop words. We talked about stop words, the words that are very common in English, that they are not, we shouldn't use them because they have no meaning in themselves. So to show that to you, I will go to term options, these term options here. Okay, and then I will go to manage stop words. So I will click manage stop words here. Okay, and in the left hand side here, guys, you can see a list of words that are built in. This is a word list of the stop words in the English language. So you'll see and, a, about, above, after, again, so many of them. Okay. Okay. So these words are excluded from the analysis. You will not find these words in the outcome here. Okay. You will never find these words in our outcome because they are stop words. Something that is nice in stop words here in JMP, and also when we move to the enterprise minor, is you can create your own stop words, right? But the question is, when would you create your stop words? Okay, now listen carefully, guys, because this is technical details based on experience. Okay, so please listen carefully here. You may need to use stop words yourself if you notice that your data set has a word that is meaningless and it is repeated a lot, right? So, for example, if you look around here, and you identify a word that you think is useless, it wouldn't add anything to you. For example, the word Amazon. All the products here are Amazon products. So Amazon is not a word that will mean anything for me, right? All the products we're analyzing are Amazon products. So why should I care about analyzing the word Amazon? It doesn't add anything to me. So what I can do is I can go to the manage stop words, right? And in under the user, I can add Amazon. Okay. Now Amazon will be excluded from any analysis after this. So once I add it here, it will not be included in my analysis. Okay, so you can see now it's gone from my list of phrases, right? This is a trick we do. If again, when do you use this? If you have a word or a token that has no meaning, you understand your data. We said it's important to understand your data, remember that. And you find that this is a very meaningless word. This has nothing, it doesn't help me with anything, right? So we get rid of it by adding it as a stop word. Okay, again, it may seem to you that it is a very unnecessary task, but if you have a word that is not useful and repeated all the time in your data, this will impact your final outcome. Okay, so try to avoid that. Another feature that is very common, this is in everywhere, not just in JMP. This is why I'm showing you these features, because they are common in all softwares that are used in text analytics. Another option here is recodes. Okay, so when I click on manage recodes here, okay, recodes are words that you want to combine together, right? So let's see some examples here and combine them together. For example, the word great and the word good, they both mean similar things. A device that is good, working fine, right? So you may want to combine them together. Right? So how do you combine them together? By going to text and then going to term options and then manage records. And then you insert the word good, for example, and you replace it with the word great. Okay. And then I click plus and they are added. When I press OK, okay, good is gone, and now great has increased even bigger. The number of great is now even greater. So text analytics is very art-like. It's very it requires experience, and I will show that all these secrets as we go on. So don't worry, I have been doing this for a while, right? Other stuff here that we can do include still in the term options is manage stem exceptions. We said that in some cases we want to avoid stemming for some words because they are they have the same root but they have different meanings, right? So here we have built in words that are like this. They should not be stemmed, right? And you can add your own as well. So if there is some word that you don't want to stem, like university, universal, or universe, whatever, you can add this word here. Okay, for example, universe. Okay, and then press OK, and this won't be stemmed. Okay, this word will be excluded from the stemming. Okay, so how would you use these features? That's a great question. Using these features depend mainly on experience and your understanding of the context you are working with. Okay, When we move to enterprise minor, I will show that to you in a better and much clear way. I will show you how to find out what words you want to combine together, what words you want to separate from each other, and so on, once we get to the enterprise minor. But basically, you need to understand the context. You must understand the context. I told you that before, but I will repeat it one more time, guys. Analytics is not about going through numbers and doing some nice statistics, and that's it. If you do this, you will end up with nice models, but these models will have no meaning in themselves. You need to understand what you are doing. You need to understand your objective. You need to understand the business you are working with. Okay. All right. So we covered a lot of ground today. We talked about text analytics and how it's different from traditional analytics. We talked about the first phase of text analytics, which is text parsing, and we applied it to this nice data set of Amazon products. Next week, we are going to go to the next phase, which is also very important, and which is converting text into numbers, and we'll see what we can do then. Sure, Mabel, no problem. Right? So I'll stop here, guys.